And the craziest part? Some of these AI agents are now executing over 10 million tool calls per day. 10 million! That's not a typo.
Wow, okay, that's a lot. I knew tool use was becoming more prevalent, but I didn't realize it had scaled that much. What happens if even a small percentage of those fail?
Exactly. That's the nightmare scenario. Imagine a critical function like fraud detection at Stripe suddenly starts returning errors because the agent using it is misinterpreting the data. The potential financial impact is huge, not to mention the hit to customer trust.
So, we're talking about a situation where the agent thinks it's doing one thing, but the underlying tool is doing something else entirely, leading to potentially catastrophic consequences.
Precisely. And it's not just about financial risk. Think about something like Uber's dispatch system. If an agent using mapping and routing tools starts sending drivers on illogical routes because of a tool use error, you have frustrated drivers, angry customers, and a logistical nightmare. Tool use and function calling are powerful, but they introduce a whole new class of failure modes that we need to understand and mitigate.
Okay, so let's break this down. At its core, what is tool use and function calling in a context of AI agents? I think a lot of people hear the term agent and immediately think of some futuristic robot, but it's often much simpler than that.
Good point. Forget the robots for now. Think of an AI agent as a software component designed to perceive its environment, make decisions, and take actions to achieve a specific goal. Tool use and function calling are the mechanisms by which these agents interact with the external world. It's like giving the agent a set of predefined abilities.
So the tools are essentially just functions or APIs that the agent can call to perform specific tasks.
Exactly. Think of it like this. You have an agent trying to book a flight. It doesn't magically know how to do that. It needs tools, like a search flights function that takes origin, destination, and dates as input, and a book flight function that takes flight details and passenger information. The agent calls these functions, providing the necessary information to accomplish its goal.
Okay, that makes sense. So it's not just about having the tools available, it's about the agent knowing how and when to use them. What are some of the different approaches to enabling this?
There are several, but a common one involves training the agent with examples of how to use each tool. You essentially teach it the syntax and semantics of each function. It's like showing a child how to use a hammer. You demonstrate how to hold it, how to swing it, and what it's used for.
And how does the agent decide which tool to use in a given situation? Is it just a matter of pattern matching?
That's where the language model comes in. The agent uses its understanding of the user's request to decide which tool is most appropriate. For example, if the user asks, "What's the weather in London?" the agent should recognize that it needs to use a weather API, not a flight booking API. The better the language model, the more accurately it can interpret the user's intent and select the right tool. OpenAI's function calling is a great example of this. They've built in the ability for the model to not just generate text, but also structured data representing the function call, including the parameters.
So, OpenAI essentially allows developers to define functions with descriptions, and the model figures out how to use them based on those descriptions?
Precisely. You tell the model, here's a function that gets the current weather. It takes a city as input and returns the temperature and conditions. The model then uses that information to generate the correct function call when a user asks about the weather.
Okay, I see how that works. But what about more complex scenarios where the agent needs to chain together multiple tools to achieve a goal? Instance, it might need to search for flights, check hotel availability, and book a rental car.
That's where it gets really interesting. This is where we move into the realm of planning. The agent needs to develop a sequence of steps to achieve its overall objective. It's like planning a road trip. You don't just jump in the car and start driving. You map out your route, identify places to stop, and book accommodations in advance.
So the agent essentially creates a plan of function calls and then executes that plan step by step?
Exactly. One common approach is to use something called chain of thought prompting. You encourage the agent to explicitly reason through its decision-making process step by step before actually executing any actions. This helps it to break down complex tasks into smaller, more manageable chunks.
Can you give me a concrete example of how this might work in practice?
Sure. Imagine you're building an agent to help users plan a vacation. The user says, I want to go to Paris for a week in July. The agent might first use a search flights tool to find available flights. Then it might use a check hotel availability tool to find hotels near popular attractions. Next, it might use a recommend restaurants tool to suggest places to eat. Finally, it presents the user with a comprehensive itinerary, including flight details, hotel information, and restaurant recommendations.
So it's not just about using the tools individually, it's about orchestrating them in a coordinated manner to achieve a larger goal. What about handling errors? What happens if one of the tools fails?
Excellent question. Error handling is critical. The agent needs to be able to detect when a tool call fails and take appropriate action. This might involve retrying the call, using a different tool, or asking the user for help.
So the agent needs to be able to reason about the error and decide how to proceed.
Precisely. For example, if the search flights tool returns an error because there are no flights available on the specified dates, the agent might suggest alternative dates to the user. Or if the book flights tool fails because the flight is sold out, the agent might search for a different flight.
Okay, that makes sense. So error handling is not just about catching exceptions, it's about building resilience into the agent's decision-making process. What are some of the common pitfalls that developers encounter when implementing tool use and function calling?
Here's where it gets interesting. One of the biggest mistakes I see is that people treat the tools as black boxes. They just assume that the tool will always work as expected, and they don't bother to validate the inputs and outputs.
So they blindly trust the tool without verifying that it's actually doing what it's supposed to be doing?
Exactly. And this can lead to all sorts of problems. Imagine you're using a tool to calculate shipping costs. If the tool is misconfigured or has a bug, it might return incorrect shipping costs, leading to overcharging or undercharging customers.
So it's crucial to validate the tool's behavior and ensure that it's producing accurate results. What are some practical ways to do that?
One simple technique is to add assertions to your code that check the inputs and outputs of each tool call. For example, you might assert that the shipping cost is always greater than 0, or that the flight duration is within a reasonable range. Another approach is to use a technique called shadow testing. You run the agent in a simulated environment and compare its actions to a known good baseline. Netflix uses shadow testing extensively to validate changes to its recommendation algorithms.
That makes a lot of sense. So it's not just about building the tools, it's about building a robust testing and validation pipeline to ensure that they're working correctly. What's another common mistake that developers make when implementing tool use and function calling?
Another big one is neglecting to properly document the tools. The agent needs a clear understanding of what each tool does, what inputs it expects, and what outputs it returns. Without proper documentation, the agent might misuse the tools or make incorrect assumptions about their behavior.
So it's not enough to just have the code, you also need to have clear and concise documentation that explains how to use it. How detailed should this documentation be?
It should be detailed enough that a human developer could understand how to use the tool without having to read the code. Think of it like an API reference. It should include a description of the tool, a list of its inputs and outputs, and examples of how to use it. Amazon, for example, has extremely detailed documentation for all of its internal APIs, which makes it easier for developers to build and maintain their services.
Okay, I see the importance of that. So clear documentation is essential for ensuring that the agent can effectively use the tools. What's the final piece of advice you would give to developers who are working with tool use and function calling?
My final piece of advice is to start small and iterate. Don't try to build a complex agent with dozens of tools all at once. Start with a simple agent that uses just a few tools, and then gradually add more complexity as you go. It's like building a house. You don't start by trying to build the entire house at once. You start with the foundation, and then gradually add the walls, roof, and finishing touches.
That's a great analogy. So it's about taking a phased approach and gradually increasing the complexity of the agent over time. So what should a software engineer do differently after listening to this? What are the practical takeaways?
First, validate everything. Don't trust any tool implicitly. Add assertions to your code to check the inputs and outputs of each tool call. Think of it as trust but verify. Second, document diligently. Create clear and concise documentation for all of your tools. Imagine you're writing documentation for someone who has never seen the tool before. And finally, iterate incrementally. Start with a simple agent and gradually add more complexity as you go. Don't try to boil the ocean.
Those are three excellent, actionable points. If I had to summarize this entire discussion, I'd say tool use is powerful, but with great power comes great responsibility to validate, document, and iterate.